Alright, welcome back to this other lesson where we are still looking at action of these buffer solutions. And last in our previous video, we were looking at the action of acidic buffer. But in this video, we are going to look at the action of alkaline buffer or basic buffer. To begin with, I need to remind you about what a basic buffer is. We say that a basic buffer is that solution that contains a weak base. So here we shall have a weak base, and it's salt of a strong acid. It's salt of a strong acid. So we are going to consider our weak base as ammonia molecules or ammonia molecule, or rather, sorry, ammonia solution, and then it's sort of a strong acid. We are going to consider ammonium chloride, and therefore, if I'm to explain the process of the action of this basic buffer, I'll begin by considering. So my first point would be consider a solution made by mixing ammonia solution and my ammonia solution, I write it as NH3 and ammonium chloride. Ammonium chloride is NH4Cl. However, in some books you may find ammonia solution written as ammonium hydroxide. Still, it is the same thing. Now, ammonia solution is a weak base. So ammonia solution is our weak base, and this is the salt from that weak base. So the salt of a strong acid from a weak base, and that's why we came up with ammonium chloride. Now, during an action of this basic buffer, we need to know that ammonium chloride is a strong electrolyte, and therefore it completely dissociates to produce ammonium ions and chloride ions. The next step is talk about the dissociation. So ammonium chloride is a strong electrolyte and therefore completely dissociates, producing ammonium ions and chloride ions, and this one can be summarized by an equation as ammonium chloride forming ammonium ions and chloride ions. Then, if that is the case, what about ammonia solution? All right. So, our ammonia solution being a weak base, it partially or slightly ionizes. So we shall say ammonia solution being a weak base partially ionizes and its ionization is suppressed by a high concentration of ammonium ions. By a high concentration of ammonium ions. Now there, that one would mean that the solution contains a high concentration of ammonium ions and a high concentration of unionized ammonia solution, because the ammonia molecules will keep ionizing. So the equation of that, we shall have our ammonia molecules ionizing in water and being a weak base, it will partially ionize, produce, being a weak base, when ammonia solution ionizes in water, we shall produce ammonium ions and hydroxide ions. Right. So that is what we are having. We've got the equations about the dissociation of the strong electrolyte and the dissociation of a weak base. But by mere having the solution, or by mere having the ionization of ammonia solution suppressed by high concentration of ammonium ions, this one would imply, let me say, therefore, the concentration of ammonia ions in solution is high, and so is the concentration of unionized ammonia molecules. Now, after having known the composition and the ionization of all these, we need now to know when a small amount of a base or acid is added, what takes place or what happens. So I'm going to remove this, then I show you what happens when we add a small acid and a small base to this solution of a basic buffer. All right. Now, what happens is that when we add a weak base, rather when we add an acid, remember, acids have got hydrogen ions in them. So, when a small amount of an acid is added, when a small amount of an acid is added, Jessica, tell us what happens. When a small amount of an acid is added, what happens? No. No tree. Let me, yes, Regan. Very good. When a small amount of an acid is added, remember, an acid has got hydrogen ions in it. Meaning that that hydrogen ion is going to react with the ammonia molecules, the hydrogen ions from an acid, hydrogen ions from the added acid, hydrogen ions from the added acid react with ammonia molecules, producing or to form crystalline is like form ammonium ions. Form ammonium ions, this is interestingly good. Form ammonium ions, thus resisting a decrease in pH. Thus resisting a decrease in pH. We need to indicate that using an equation. What happens when you add an acid? We have said that the hydrogen ions will react with ammonia molecules. So you will have ammonia molecules reacting with the hydrogen ions of an acid added. Alright? We are going to produce ammonium ions. Now, that is when you add a small amount of an acid. What about when you add a base? When a small amount of a base is added. Now, a base has got hydroxide ions in it. Now, I want Okero to tell me, when you add a base, the hydroxide ions, what will they react with? Okay? Which ions will hydroxide ions react with? Yes, okay? Very good. The hydroxide ions will react with the ammonium ions from partial ionization of ammonia to form ammonia solution. Very good. So we shall say that when a small amount of a base is added, alright, the hydroxide ions from the added base react with ammonium ions, from partial, alright, from partial ionization of ammonia solution, to form, what do we form when hydroxide ions react with the ammonium ions? If you are not sure, you can first write the equation. To form, we have ammonium ions plus hydroxide ions. We shall form ammonium molecules and water. So now, if you're not sure, you can as well first write like an equation or somewhere, and then you bring to form ammonia molecules and water. What would this one imply? When you form ammonia molecules and water, this resists an increase, resisting an increase in pH of the solution. An increase in pH of solution. Otherwise, also someone here, on adding a base, one can write this point as, you see, when you add a small amount of an acid, also the hydrogen ions from an acid can react with the hydroxide hydroxide ions from partial ionization of ammonia to form water. And the moment you form water, it means that more of the ammonia will keep ionizing so that it replaces the used up hydroxide ions, keeping the pH of the solution almost constant. So, if I'm to summarize this like the way I did in terms of equations, action of an alkaline buffer, if I summarize it for you in terms of equations, it means that the first equation will be, you need to first know that the first step of these numbers is knowing the components. For alkaline buffer, we have considered ammonia solution. Which ammonia solution? Partially ionize. Here I forgot the water. Partially ionizes in water, form ammonium ions and hydroxide ions. In the same way, ammonium chloride, this is the composition of an alkaline buffer or basic buffer. It will completely ionize, being a strong electrolyte, form ammonium ions plus chloride ions. On introduction of an acid has got hydrogen ions. So the hydrogen ions will react with ammonia molecules. When you put an acid, introduction of an acid, the ammonia molecules will react with that acid, producing ammonium ions, which resists a decrease in pH. On introduction of a base, now it will be the ammonium ions from the partial dissociation of the ammonia molecules. So the ammonium ions from there will react with the base introduced to form ammonia molecules and water. So to replace the used up hydroxide ions, there will keep, otherwise, if you don't want to use this, because when you use this, you have to tell me that this avoids or this resists the increase in pH. Or you can tell me that the hydrogen ions here on adding an acid, the hydrogen ions will combine with the hydroxide ions from partial dissociation of ammonia, forming water. So to restore the concentration of hydroxide ions, ammonia molecules keep dissociating, resisting the changes in pH. And this one will clearly tell you that the pH will keep constant when an acid or a base is added to a buffer solution. So in our next video, we are going to be deriving the equations of the Henderson-Hasselbalch equation so that we see the calculations about buffer solutions. I wish you the best. Don't forget to subscribe.